Hello, welcome to my bench. Today we have this big hunker right here. This is called an FXi250. It's made by Broadcast Electronics. And basically it is a full FM transmitter in a box. Its main job is to be the preamp for a large transmitter, like 7,000 watts or whatever, 7,500 or 50,000 or whatever you've got, and you feed the output of this into your main transmitter to get your output up. The main transmitter takes quite a bit of power to run them sometimes it's 12, 15 watts, but this one will go to 250. I got this thing in for repair. The guy told me the fuse was missing or out of it, and that he didn't know if it worked or not, and he wasn't going to plug it in. I said, good idea. So I took it all apart, took it out, and I found the fuse rattling around inside, and it was indeed bad. It was a little 1 amp fuse. So I took the power supply out, and this is the power supply right here. So this fuse that was rattling around was right down here. It's a little half amp fuse. It's F8, I believe. Yes, F8. And it is in the 12 volt circuit, which we'll see in a bit. There also was a modification to this unit, which I do not believe is supposed to be there. I can't find any information on it. It had this and a little cap. Where's the little cap? Yeah. This here and this little capacitor. It had those attached over to right there where that capacitor is. It had it right there on that end of that capacitor, but that capacitor was gone, and the wire stretched around like this from the side, came around and attached somewhere over here, but it wasn't. It was just flopping around. So I took that mod off, got it back to the way it's supposed to be. And then also there was another modification, a little one, which if we can come down here and show you, if you look right down in there, that little opto-isolator right there, it had a capacitor going from that pin to that pin. That would be 4 and 6 of that. That's not supposed to be there anyway, and it's also repeating something that's already there, so I don't know why that was. I took that off and checked around on it and checked all of the components. Now, on these big power supplies, it's usually best just to do a good look around first, because you plug one of these things in and you've got shorted parts, you're just going to replace more shorted parts that you shorted on your own. So basically you check them all out, and I'll give you a couple of hints on what goes wrong on these things. Basically, you've got several different power supplies. This is your hot side right here. 12 volt. There's 12 volt power supplies, just linears, and your AC in, and a bunch of other stuff, and your telltale LEDs over here for if your voltages are high or low. That'll come on and tell you whether your 8 volts is high or low, or your 12 volts is high or low, or your 48 volts, and a bunch of other stuff. These are actually driven from another board in the machine called a controller board, and those, they don't actually come from, say, right here, 16 volts, over to here to tell you whether it's high or low and measure it. It's actually all done through the controller board that comes back into this pin. So you got your main drive voltages here, and then you've got your other derived voltages from your switching power supply, which is down in this section. You have several supplies. This over here section is run off of this U10 right here, and its associated stuff, and this gives you a bunch of your voltages. Then over here you've got two big FETs and this transformer, and a couple of big diodes over here, which gives you your 48 volts for your power output, for your RF. It's not nothing magic in it. It's just, fairly complicated and pretty robust. All right, so I checked all of that. These guys go bad for the 48 volts because they're under the most load, especially if this thing's at 250 watts out. I mean, it draws a lot of current. 250 watts of 48 volts. Figure it out. These are good. These are all good. There's a transistor under here called Q10 that needs to be replaced. And it has, from the factory, there's a factory upgrade for Q10. It'll pop if you, the original one would pop if you had a voltage drop. Your power went out and then came back up again real quick. That thing would pop. So there's a Q10 replacement that involves putting this little capacitor right here, which actually goes across a little capacitor on the board, and that Q10 that's in there, which is a big heavy FET. Okay, so that is a factory upgrade that had been done on this, and it was okay. The other thing goes wrong is this big old giant 4.7 ohm, I think it is. It's 10 watt, 4.7 ohm or something like that. They open, and when they open, everything else just quits because the voltage goes through there. So anyway, let's take a look at the schematic here, and I'll show you what actually had died when I got to looking through this thing. And I didn't call it schematic, I called it manual. Okay, here's your manual, and this is the first page of your power supply. It's pretty complicated power supply. Here's the first page, here's the second page, here's the third page. Basically, they're separated into hot side, what we'll call the hot side. This whole section here is hooked up directly to the mains, and you've got over here in this section you got all your 12 volts and your turn on voltages. Here you've got your higher voltages and some of your derived. Let's see, where is it? There's your B plus right there, F9. That all comes off of this portion of the schematic, which is all over on the right side as you're looking at it, the right side of the board. This portion of the schematic is your switcher power supply voltages. Up here you've got the 48 volts to drive your PA, your power output amp. It comes through this right here. This is a PWM. It's a switching power supply regulator, and it is controlled with 0 to 5 volts input, which we get from elsewhere in the controller board, which makes this change the duty cycle to make for your switching power supply to come out here for your 48 volts at a fair amount of amps. Down here we've got the same IC is up here, but this one is fixed. It does the same job. It goes through this opto-isolator, which we looked at on the board there, that had the capacitor across 4 and 6 So it had the extra cap between here and here. So 6 and ground. Well, there's already a capacitor between 6 and ground. I don't know why people thought they needed more, but you know, I'm not smarter than the engineers that built this thing. I'm going to take it back to the way it was. Then it goes into this, I see here, this U12, which is a 4429 switcher for this Q10. Remember that Q10 that we had? That one is the one that pops if you don't replace it. It goes into this transformer. This transformer then gets the output gets rectified for your 4 different voltages. You've got your plus 16, your plus 8, your minus 16, and your 24 volts. So those are all your voltages that run on the rest of this stuff, along with the 48 volts up here. Well, if we go down to this part of the schematic, this is all of your digital logic, so to speak. A bunch of opto isolators for push buttons, for fan on, or well, that does it by itself, but for a fault reset, and for voltage control, for your 48 volt sample coming back to tell you, what you are actually running. It has a few of its own power supplies, like this minus 12 volts here, and what else has it got? I don't know, a couple other things on here, but it also has your 350 volt test point and a bunch of other stuff on this. So this here, this part of the power supply is what we're kind of interested in to begin with, okay? And mostly this section right in here. Why? Well, here's F8 right here. That's F8. And that F8 is the one that was blown up on the board and rattling around inside. That goes to this D19, which is a full wave bridge rectifier. The output of that is fed, let's see, it goes up 330K. It goes up through there, it goes down, and it goes into this. For one place, it goes into this LM57 or 2576 voltage regulator, and out to your 12 volts. Well, okay, that's interesting. And then we also comes down and it goes to right here your Q6, which is a IFR 520N for 12 volt S. So you've got plus 12V, you got 12 volts S, and it also, where else does it go? It also comes down through a 100K resistor to this. Not exactly sure what that does. Oh, it turns on this relay. Okay, these relays, this relay here, and this relay here, and this relay here, and this relay, they all come on after a period of time when you turn it on, which we'll find if you can hear it later. Anyway, so since that fuse was blown, that was the first place for me to look after I took all the junk off of it. And so let's see, turn the manual off. Okay, so I started tracing it out. Well, it was kind of a long process. The first thing that happened was I went through it, and I found that there's another fuse, and it's right over here, and I got to get this replaced. Right now it's been replaced with a very small piece of wire, one strand of 24 gauge, which is good for about 1.5 amps. I got to get one for that. I don't have it right now, but this is F6. Let's go find out what F6 is, just to show you on the manual. F6 is down in this section on our derived voltages, it is right there. F6 is a 1.5 amp for the minus 16 volts. Okay, so that was blown, and that's a service mount, and that's it. That's all it was. I went, okay, so we got our F9 or F8 and our F6, and I jumpered that, and I plugged it in, and I got nothing. Where we're at right now is right here on this IC, which is that IC right there. Alright, so make sure everything's good over here. Turn it back on. Alright, so we should have coming out of here all of these voltages. So over here is your plus 16. Turn on the meter again. Alright, here's your plus 16. We got nothing. Here's minus 16. We got nothing. Here is TP18. TP19, we got nothing. TP18, we got nothing. We got nothing. We got nothing coming out of that transformer. So we got to find out, are we indeed getting voltages to this guy? So that would be B plus on this VCC is pin 15, which is right there. We're getting 1 volt. No, we're not getting anything. That doesn't make sense. What we got here? We got a couple of diodes. Well, here's our 12F and our 12S that we got from this sheet up here. And let's see, that's on the end of D38 and D39. Here's D39. What do we got there? We got 11.27 volts on one side of D39, which is 12S. And we've got nothing on D38, on either end of D38. So we haven't got a 12, turn this off. So basically we haven't got a 12F, which is right here. We do have a 12S. I had my 12 volts over here on the hot side. And I had the 12 volt turn on voltage to this Q, or this IC10 over here, U10, which is a, it's that, what do they call it? UC3826DW. That's the switching power supply regulator. So driver. So it had voltage to turn on for the 12 volts from over here, but it wasn't turning on. I went, okay, that would make sense, I guess, because what happens is you get the 12 volts from over here that turns this thing on immediately. But if we look back at the manual again, if we look over here, you see that you have your 12S, which we derived up at the top, and that was good. Then you got a 12F, which we've not seen before, and a 12B. All right, so I checked these through, and I had 12S. I did not have 12B, and I did not have 12F. Well, I had 12B, but it was low. Basically, it was what was going through from 12S up out. So I said, So I started tracing out the 12F. Well, the 12F comes from here. The plus 16 volts goes into LM317. It's regulated down to 12F. That's what feeds this IC into its VCC when the thing is turned on. So as far as I can tell, the 12F starts it up or the 12S starts it up. The 12F, once it gets going, takes over, and it keeps going. I don't know the actual purpose of the 12B. I don't care. Anyway, didn't have it. And it wouldn't have it because this was bad. This chip was bad. So I've got a couple of those, and I swapped it out. Ooh, too much air. All right. Let's warm this up a little bit. Fortunately, this is in the days before lead-free solder. This thing's about 20 years old. And lead-free solder wasn't quite so prevalent at that point. All right. Well, if this chip wasn't shot before, it is now. Oh, crack. Okay, so finally. So yes, it was glued down in the middle. Wow. That was just horrible. Well, looks okay. Doesn't look like I took anything else off the board. Man, that was tough. Okay, well, let's clean it up a little bit. It's kind of hard to get in here. Yeah. Eesh. No, just one, thank you. Okay. All right. It looks pretty good. I don't see anything missing. Yeah, it was definitely glued on the bottom there. All right. And these chips are not really expensive. They're a few bucks each. So, you know, it's not like I'm wasting a lot of money here. Just if you've got, I mean, we can't prove anything until we get some other voltages running. All right, we'll turn you off. I'm going to hand solder this. It's big enough. All right. Yep. Oops. Sorry. Smacked you. Ah. Come on. All right. Got a blob. Clean up the sides a little. Ah, get off of there. Thank you. Now, let's see. And what's the verdict? Just doing a final check here to make sure I didn't get everything. All right. Let's take a look at it. See how it looks. It's not going to be perfect, but it might not be awful either. Not bad. It's a tiny bit crooked, but I'm not going to take it off. Nope. I'm not going to take it off. Okay. Well, pull you back out. Straighten you back up. Okay. That wasn't the prettiest job in the world. Well, what do you think? Think it'll work? I don't know. Off? Death cord engaged. Let us bring up the meter. Get me ground. And over here. So, everybody okay? No blobs of solder underneath the board. It's on. No. We still do not have any voltages. Turn you back off again. So I swapped this guy out, and now I suddenly had an output of this, but it still wasn't doing anything. It was just the ramp. There's a ramp in there to control how fast it goes. I think it's 500 kilohertz this thing runs, something like that. Anyway, so I had it was running now, but nothing was happening. And I'm thinking, okay, well, that goes right into this right here, this opto-isolator. And if you look at, that's a fast switching opto-isolator, and it has a transistor, and it looks like some sort of that's a symbol for a op amp. So basically there's something in there in a transistor that turns it on and off, which then goes directly to this 4429. Well, I did measures on this, and I got the diode across what I'm supposed to there. I tried to do as much as I could to measure this, but I did get between 5 and 4. The transistor was good. So I said, well, okay, we're going to count that as maybe that's okay. So I ordered and got one of these 4429s. The 4429, if I get a picture here, I'll pop it up for you. Is, you know, if this isn't running, you got no 16 volts, because it's driving this transformer that drives and gets all of your other voltages. Your plus 16, your plus 8, your minus 16, your 24. If this transistor is not being turned on and off to open and to raise and collapse the pulse on this transformer, nothing else is going to happen. All right. So I replaced this guy. Get rid of you again. So I replaced this guy, and that did it. Now we got all of our plus and minus 16 volts, and 8 volts and 24 volts and 48 volts, and you can't measure the 48 on here because remember, it's being driven by a 0 to 5 volts, 5.1 volts for your PA output, and I don't have any, sitting on the bench, I don't have any voltage going to it, but I put it into the 250, and it does work. I just wanted to show you the logical steps that I went through to get this thing done, and these are really kind of a pain in the neck. They're really, really complicated. They're very rugged, but they won't take much abuse if something happens. This one got hit by a power surge. It got nailed hard. The guy says, yeah, it was running fine, and then all the lights got really bright and this died. It's like the guys at the electric company, they must have both of them didn't switch at the same time and doubled up on volt. I don't know. That's a guess. But anyway, it took a hard hit, and but now it works. So now I still got to get this little fuse to replace this thing, and I don't have a half amp. I got to get a half amp over here for one of that fuse, and this one will be done. Anyhow, just wanted to show you this. Oh, and this, you've seen this sitting here. Well, here. This is called a death cord. Do not use this. Nobody. I've been doing this. Sorry about the finger. My mobile home got me when I gave her away to somebody, and her parting gift was to slice my finger. These things are very, very dangerous. If you've got any doubts about your abilities at all, do not use one of these things. If you are doing something like this, you are doing so at your own risk. I will not take responsibility for it. I'm an idiot. I've been doing this for 40 years. Anyhow, so there's my power. I can't even run this through a 150 watt light bulb, because when it first starts up, it draws almost 3 amps. So let's just for a second anyway, 3 amps. Let's see. Let's get the meter up here. There's my meter. We'll hook it up to 0 level, which is 0 voltage, which is right there. And we're going to turn this on. Now, I want you to listen and see if you can hear this. When you turn it on, it comes up and then it goes boom, click, 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 and all of these relays pop in. Are you ready? Would help if I turned on the power supply. Okay, here we go. And the lights flash. All right, so there we go. We now have my on voltage. Yes. There's my 16.25 volts for plus 16. There's my minus 16, which I'm supposed to have. I believe 8 is over here. Here's my 8.8 volts. If I come over here, where is it? There is, don't short anything out. Oh, that one is referenced against a B, not ground. And this one here, there's my 12 volts, 12S, I think it is. Yeah, 12S, that turns the whole mess on. This one is 12, but it's referenced against a different ground, which I can't get to right now. They don't give you a nice ground out someplace for this stuff. You have to actually poke, and one of them you can get is right down there. But trust me, it's working, or nothing would be working. And none of my lights are on. Of course they're not, because it's not connected. There's no plug over here connected to the controller board to turn them on. Anyhow, click. There we go. It's fixed. I'm going to put it into its unit, put it on the burn-in bench over here, and plug the thing up, put about 25 watts on it into a cantenna for a couple hours, make sure everything works good, and send it back to the guy and make him happy. I am. That was an uphill battle on this one. Off, yes. Don't do this. Anyway, so there you go. Hey, thanks for watching. Got any questions? Put them down in the comments below. If you don't like the way I do it, tell me, but what else? And don't forget to register, and thanks for watching.